Have you ever pondered why some objects float and others sink in water? The answer lies in two key factors: the object's density and the buoyant force acting upon it. Let's start by understanding density. Density is essentially how much mass is crammed into a specific volume. It's like packing your suitcase for a vacation. The more you pack, the heavier it gets. The density of an object depends on the materials it's made from. For instance, water's density is 1 gram per cubic centimeter. Now imagine a rock. It's denser than water, so it sinks. Why? Because it displaces more water than its own weight in water. On the other hand, take a piece of wood or styrofoam. These materials are less dense than water, so they float. They displace less water than their weight in water. Next, we have the buoyant force. This is the upward force exerted by water on an object submerged in it. Think of it as the water molecules pushing against the object, creating an upward force. If this buoyant force is mightier than the object's weight, the object floats. If it's weaker, the object sinks. This brings us to the concept of the Archimedes principle. This principle states that the buoyant force on an object submerged in a fluid equals the weight of the fluid displaced by the object. This principle is key to understanding why objects float or sink. Consider an iron nail. It has a density of about 7.8 grams per cubic centimeter, which is more than water's density. Hence, an iron nail sinks in water, but a piece of wood with a density of about 0.5 grams per cubic centimeter floats because it's less dense than water. And what about a life jacket? It's made of a material less dense than water. When a person dons a life jacket and plunges into water, the buoyant force of the water is greater than the person's weight, causing them to float. So, the next time you see an object floating or sinking, remember it's all about density and buoyant force. Whether an object sinks or swims in water hinges on these two factors. Fascinating, isn't it?